Okay, welcome back everybody. All right, just to recap what we were doing, we are trying to understand cyber assets in cyber physical system. Also try understand if we can understand the critical assets so that we can prepare better in terms of understanding what kind of risk it could have, what kind of solutions tools we have, and what their effectiveness look like. Right? The tools and solution we have, are they sufficient enough to handle the critical situations where someone can attack our important assets. So, let us continue with this one. So, we talk about something called asset discovery. Yeah. Now, we kind of understand when you look at the asset discovery, we are talking about the hardware, which are hardware physical devices. We are talking about softwares. Softwares could be applications. Software could be different configurations management system. For example, we talk about virtualizing physical configuration into software, software virtualization, software defined networking, and so on, those kind of concepts. Network devices, we talk about routers, switches, and other types of devices. Now, when you identifying these devices, it's also important for us to build that understanding that which of these devices are cyber physical in nature. Some of the, as we said, some of these devices are physical devices which are not connected to the internet, and they have very low risk of compromise. Since they are not connected to the internet, we believe that they are not part of cyber world. Yeah. There are devices which are connected to the internet, and there is a high risk for cyber attacks. Now, if these connected devices, if they are connected to the off field devices in some way, then there is always a risk to other devices as well. Then we look into something called intangible assets. So, there are, for example, your intellectual property. Yeah? You developed a method that does something. For example, I created a method for, or created a tool for cyber cyber risk assessment. Right? Companies patent these methods. What is the reason? Claiming that this is their method, right? And if anyone cannot use it without their permission. If you want to use it, sometime they ask for certain profit. Yeah, you pay certain amount in order to use this technology. So that's how researchers develop new methods, and they patent it. Now, patents also, again, it's a broad topic to understand. If you have developed a patent in India, that's only valid within India. Yeah, if you are just asking for a patent, and so on. So the patent in the country, international, and so on. So in how many countries you want to cover, you have to apply for patent in those countries. Okay, what if someone steal those documents, destroy those documents? Yeah. So those are really, again, important documents for us. Now, we talk about asset discovery tools. So we said there are two ways, passive and active, the way we do it. There are a number of tools available. We talk about Nmap, but there are others as well. Now, when we run this, basically when I say network scanning tools, they identify the devices or assets which are on the network. Yeah. On the other hand, there might be some devices that are part of the system, but they are not connected with internet. Yeah, they do not have IP address, but they are part of the system. They are exchanging data. using lower layers. One of the examples in substations, we have IEDs, right. IEDs use protocol called GOOS, which is generic object oriented substation event protocol something. This protocol does not require IP address. So, it communicates between IEDs and so on. Right. So, there might be some IEDs which are maybe if they are not connected to the network, then your network scanning will not detect them. Apart from that, there might be some other hidden devices, silent devices, edge devices that are not there. If you are putting your data in cloud, when you scan it, it does not show your storage, because you are putting data somewhere else, but that is again a critical asset, yeah, which is not part of your system, not part of your infrastructure, but it is important for you. Silent devices, for example, printers. So, if you have a print, now we got smart printers. These printers have IP addresses where you can print, scan, photocopy, whatever, you can do all those things. But if we are talking about a typical printer which is connected to the PC generally, and most of the time these printers are off. Whenever you need to print, you turn it on, print it, and then off. So, if the printer is off and you are running the scanning tool, it does not show, right. But if my printer has some ways a kind of little smarter where I can plug in USB, some printers allow you to plug USB, select your document and print it on the spot. If you have a malware in your printer, in your USB, put in the printer, that might inject into the system. So, those devices also need to be we need to take into consideration when we talk about asset discovery. We also need to pay attention to the asset which are not part of the network in a direct way, but they are part of the system, right. Obviously, when we have inventory, asset inventory, we would like it to keep up to date, not just from the list point of view, but also from vulnerability point of view. We wanted to know what assets we have, what kind of potential cyber vulnerability they might have, and you keep scanning from the data set, CBE or whatever you pick up, to understand at this point of time, what is the status of my asset vulnerabilities. Sometimes the patches are not available immediately, so you just wait and watch in terms of if it is available, you just apply it on, for example, IT system. Integration, when we have multiple software which are interacting to each other, outcome of one or report of one is go, input of others, and then security becomes a little more difficult, right. So, we know something called black box, white box testing. Yeah, what is that? Static testing, static testing and dynamic testing in a way. In software engineering terms, we say black box and white box testing. Black box means we are not really looking at code, we just want, I am giving input and it should produce desired output. Yeah, that is what we call black box. We are not really concerned about what is in the box, what does the code look like. On the other hand, white box, we go deeper, look at execute the code and debug code to see are there any flaws, are there any exceptions, right. Because sometimes the intention of your attacker is to disrupt the system. You created a software that takes input integers from 0 to 9, but you have not put a condition. What if I am rather than putting the integers, I put alphanumeric numbers? What will happen to the system? If you are not handling this exception, your software will throw some errors, bugs, yeah, which is not good for your reputation. It might create disruptions in the system, right. In the similar way, when we go for security, in the security side, we have static testing, dynamic testing. Static testing, mostly we look around kind of a black box, yeah, and in dynamic testing, you go deeper and look at everything. roles and responsibilities. So, we talk about why there is a need to have strong passwords. We also talk about most of the IoT devices have default passwords or no password at all, because these are hard coded passwords. And it is not just the problem with IoT devices. In most of the proprietary device systems, for example, if you take example of cellular networks, your SIM cards. So, at the time of manufacturing SIM card, they injected a key, symmetric key to it, and the same key is at their server. So, whenever you turn on, try to connect it, there is an authentication process takes in between. Since both ends having the same key, they can encrypt and decrypt, for example, right. There are ways someone can crack the key as well, but since it's been hidden, kind of they don't reveal what algorithm they are using, what is the key size, and so on. So, it's been considered secure in the past, but as of now, we don't really promote these kind of systems. Rather, we believe that security algorithm should be known to everybody in a way, even the attacker. You design a system in such a way you don't hide things. You can hide keys, not the algorithm. And despite of that fact, even if your system is secure, then we are okay. Right. In terms of vulnerability scanners, there are multiple tools available in the market. And in this, we are not really particular about that which particular scanning tool we want to use, vulnerability scanners. We are more interested how I get to know what are the vulnerability in my system, irrespective of whatever tool I am using. Yeah, if there is information somewhere in the data set, repository, I can use all of them. But my goal is to get to know, I got list of assets, what could be the cyber risk, cyber vulnerability in those assets. I want to list them and understand. Are there the patches are available to that? If yes, I will learn and update my system. And again, we talk about how the system work, IT versus OT. In an IT system, is pretty straightforward. You can easily immediately patch your systems, but in OT system, it's not easy to patch. Then you go incident response plan. So, incident response plan is one thing that we have learned. We need to be proactive rather than reactive, right. So, you don't just wait until something bad happened to you, rather you figure it out what is wrong in your system, what are the issues in your system, and then you prepare yourself, fix those issues, and get some tools that can help you in the case of attack. Okay, we already talked about asset maintenance. So, the way it works, once you got a list of assets, we look for asset classification. So, understanding what type of asset we have, hardware, software, and so on and so forth. We look around what is the valuation of those assets. As an attacker, your intention is to damage those components which are really costly or which are really critical to the service. Yeah. If you have an asset that comes, so in India it's really hard to find. You have to order, that comes from US. It takes 6 months to be here, and that cost X amount, which is really critical to you, because once this is damaged for 6 months, it's gone. Nothing will happen, right. So, we need to understand the valuation of the assets in terms of cost, in terms of availability. Asset relationships, there are certain dependencies as we talked about. When we are talking about certain operations, within operations, we have seen like outcome of one process, part of input to another process. So, we always look around what is called cascading impact. When one thing fails, it has direct or indirect impact on the other processes. Other process might also fail. Other devices might also destroy. So, we need to understand those scenarios and build a relationships which asset can impact other assets. And then we, based on that, we try understand what are the overall weaknesses in the system, what are the assets critical to us, what sort of their time and cost look like if we need to get a replacement, and what could be our backup plan. So, we prepare with all of these things. Okay, so what we did is we came up with a framework to identify cyber physical assets that improves situational awareness. Right. So, we look around the communication layer, we look at the power system layer, and then we try understand what are the interdependencies between physical and cyber layer. Is it possible that attacker target one of the communication layer device and inject an attack that propagates to OT system, impacting power system? Is it possible someone could temper power measurements, power devices that has some impact on the digital process, risk assessment process that we have? Yeah, we might end up with having incorrect assessment if the input is not correct in a way. So, we wanted to understand all those things and try understand what. Okay, so this is what we did. So, you understand power system topology. Now, you understand what asset we have, what devices we have, but again topology is again an important element to it. The way you have connected your device is an asset to it, right. I got 10 devices, all devices I have connected to this computer. There is always a single point of fail. What if this device is down? Everything is down, right. If there is only one generator in one part of a region that providing service to that region, what if that generator is down? So, there is no electricity in that region, right. Either we have to supply from somewhere else or. So, we need to understand topology of the system, what devices are there, in what connections there, and I believe when we understand topology. So, I am not going into detail, bus, ring, mesh, right, we all know that. Okay, so, once you understand topology, we look into how we identify assets, system network, we perform risk based assessment to understand what kind of potential cyber risk these assets might have, identifying critical assets and critical paths. Now, understand critical paths now. What is critical path? For an attacker, so when we talk about attacks, we have to think like an attacker. Yeah, you have to think about what are the different ways by which you can reach to your target and damage the system which is your goal. So, let us say if you want to go from a device A to device D, there are multiple paths, right, that you can follow. And obviously, in this path there will be some intermediate critical assets, some of these, not all, but in some path possibly there will be some critical assets. Some path might not have, some path may have few, some path may have more, right. As an attacker, we wanted to follow the path which are having maximum critical asset, so that I can make the maximum damage to it. Even if I am not able to reach from A to D, I know my B and C assets are still critical. If I am able to damage one of them, I am still halfway in terms of attack, right. So, our intention is, or sometimes attacker can go passive, does not do anything to the intermediate nodes and just target the final, right. So, as a company owner, our intention is to understand critical paths where attacker can create large damage, maximum damage, right. For any point from A to D, what are the typical possible paths? Out of these paths, where you see critical assets in that, and we need to identify those paths. Those paths we are calling critical paths. We need to understand what will happen when someone attack follow this path. When they reach from A to B, do we have anything? Do we have any solution that can hit? Say, okay, there is an attack going on which is targeting this or propagating in this way. Can we stop this at device B, and so that it does not propagate further? If not, it will propagate to C. Do you have anything that you can hit on C? If no, it will go to D. Can you stop it? Can you if no, can you mitigate the impact of the attack? There will be damage, but can we reduce that damage in some way? Yeah, is there anything that can quickly work for us? Maybe you detach the network, isolate part of network, disable device, shut down it, whatever. So those are quick action you can take, but then the whole point is to understand what are the critical assets and critical paths in the network, and then possibly you can evaluate the impact. So we created a simulation environment where we can understand what are the critical asset, critical paths. You run some simulation, perform some attacks to see what kind of impact they may have. Now, this is just we were looking into literature to understand what are the possible solutions people have come up with and what their gaps look like. One of the things that most of the solutions didn't do is ranking. So, when you say understanding the impact, how would you quantify impact that? So, let us say when someone target device X, I might lose, might be few lines will be overloaded, right. Overloaded means there is a demand in a region. So, you are increasing the load, for example, as a malicious activity. You are saying in this region there is a large demand, but then you got generator with certain capacity. It can produce only that level of energy. Yeah. So, there are electrical engineers who look into this situation, either they increase the capacity, generation capacity if they can. If not, then they can support the energy, they bring energy from other networks, yeah, within power system. So, we also wanted to understand when there is an adverse impact. If there is no adverse impact, we are okay, we do not care as long as system is stable. But if we think that system might be unstable, it might have some issues, we wanted to quantify and understand whether it is a low impact, whether it is a medium impact, whether it is a high impact, whether it is a critical impact. It is an emergency situation that you have to act, otherwise you will be losing half of the networks, for example. So, it is very important to quantify those things. And also you are running incident responses. As I said, is it possible for us to stop the attack in between on intermediate nodes or devices? For that one you need to have incident response, effective incident response, and you will be able to do that once you understand what is going on. Our first intention is to understand the early detection of attack. If you are able to detect an attack at early stage, it's comparatively easier to stop it. Yeah. Otherwise, attack becomes more powerful and it becomes much harder for you to see what is going on, right. But then early detection might not give you the accurate understanding that what kind of attack it is. There is some manipulation in this. This might be because there are faults in the system, yeah, or there might be some issues, some attack, actual attack. So, sometimes it is also difficult in situations to understand whether. So, for example, in power system we also send certain routine command. As I said, there are operators looking at the big screens and they are adjusting load and energy depending on supply, energy supply, yeah, what they need to turn on, turn off, increase, decrease, whatever. So, they in the whole day they are sending routine commands to increasing something, decreasing something, turning off circuit breakers, turning on, connecting, so on. And sometimes there could be an attack as well. There is an attacker that can also open or close those circuit breakers. So, sometimes it becomes impossible to understand whether it is a legitimate operation done by the operator or actually it is a cyber attack, right. Therefore, it is important to understand the impact of it, right. Second, we say detect on each stage with what if scenario. So, within the simulation you can create what if scenario saying what attacker target asset X, critical asset Y, Z, whatever, what they follow this path, what kind of maximum damage they can have, they can create. What if we do not have any tool or solution that can stop it? So, what will happen in the worst case? So, we wanted to understand all those scenarios, so that we are better prepared for the worst. Yeah? If you prepare for the worst, everything will be much better than this. One of the problem with the company, they are not prepared for the worst. They don't understand, they don't want to pay, they don't want to spend money on it. And then people always say, oh, something happened to them, it will not happen to me. Yeah? And you don't realize until unless it happens to you actually. And as I said, third, understanding the worst case impact. So, we wanted to understand, if we don't have any tools, effective tools as of now, and let's say attacker travels this critical path, what would be the maximum damage that they can have. And in that condition, what tools, what capability, what effort we need to put in place to mitigate the impact. If you prepare with those response and plan, you are much safer. Now, we already talked about attacker's capability in one of the lectures. Insider attacker, again, fighting against external may be easier compared to insider. Insider might have enough, lot more knowledge to feed part of the attack. So, we came with an approach which is based on graph modeling, right. So, in the graph you have nodes. Let us say I am representing nodes as my devices, and you got edges as a connections, right. So, I might have x number of devices, and this is how they look like in terms of topology. So, I can represent this is how which device is connected to what in. Now, we are running 3 phases here, 3 or 4 phases. One is pre-processing. From cyber side, we wanted to understand again what asset we have, cyber or communication assets, what services we are running on those devices, which operating system we are having, and communication between host, which device talking to which. Yeah. And then we are mapping vulnerability based on operating system and open ports. So, you got a server, for example, running x number of devices, x number of services using number of ports. And sometimes we forget to close those ports once it is done. So, what is the role of port? So, we run protocol with something called socket address, which is your IP address plus port number, right. This is TCP runs on port number 25 or whatever. Yeah. FTP runs on this port number. Yeah. SMTP runs on port number X. What does it mean? What if we don't have port numbers? What will happen? Let us say I am running here on my computer, on my laptop. I have an email screen open. I am writing an email. At the same time, I also have browser open, yeah, where I am fetching some information. I am also remotely connecting to some server with file transfer or whatever. All the data coming back to here. How would my system get to know which data goes to my email, which data will go to my files, or which data will go to my browsers? Port numbers. So, that is where port numbers help us to understand if your data is coming to this port, it will go to that port, yeah, based on the protocol that you are using. That is where we have protocol running with the specific port numbers. Okay. So, as I said, in the graph modeling, we have host, nodes and edges. Now, we are looking into what kind of devices we got, what could be vulnerability there. And then we are also doing something called vulnerabilities between centrality. So, I wanted to know in any 2 nodes, and more importantly when I am saying critical nodes, for between any 2 critical nodes, what are the possible vulnerability? What are the total number of vulnerability that I see? Similarly, there is a host between a centrality, yeah, between Any two node, how many nodes, how many devices are there in between? For any of those devices, what is the incoming and outgoing connections? Yeah, this will help us to understand which device is more critical in this environment. What if you cut down this communication somewhere, how this will impact the whole system. In a similar way, we also did do this for the power system. So in power system, you got something called buses, you got lines, you got transformers, and other devices, yeah, loads, capacitors, and so on. For each of those devices, the way they are connected in the network, we wanted to understand criticality. You're representing buses as nodes, transmission lines as edges, and then similarly you perform electric degree centrality, electric between centrality. And then once you have both ready, then you want to plot the gap, understand the interdependability. Right? Now, once you are done with this, we wanted to understand cascading failure. In order to understand interdependability, we can theoretically sometimes can see that this device, since it's using input of this, output of that, depending on other device, right? But sometimes it's not as clear to understand the cascading nature of it. So what we did is different colors represent different type of devices. So we have here number of substations. So 1, 2, 3, 4, 9, 10. The 10 substation we consider. There's one you can't see, but there's something SCADA system. So the control center is here, and then we have around different substation, different devices, and so on. Devices are connected in some way in each substation, and substations also connected to the control center in some way through RTU. And here, what we are trying to do is trying to understand when the attacker target this device or that device, how this will impact it. Now, one of the important lesson is when we think about how to fix this. Obviously, we look around security solutions, but more importantly, there could be some problem that you can easily fix by changing the topology, changing the connections. Right? Maybe there's one device having single connection. We might have, if you create multiple connection, if one path goes down, you still have ways to get the data, for example. So we actually modeled Ukraine power grid attack. We'll be talking about in one of the tutorial, not today, and try to simulate in the same thing what attacker did. If something like this happened, can we understand the dependencies? Can we understand how to mitigate the impact? Can we change the topology? Can we change the connection? Can we take off devices, and so on? So, for example, in this scenario, we got 3 generators. If you see here, so these are generators. The symbol, right? It's not going to work on this. Okay. These are the generators 1, 2, 3, and from these generators I got several circuit breakers. So if you see this, these little red, yeah, these are little boxes, circuit breaker, which is kind of MCV. You can, if it is open, there's no current. If it is closed, there's a current here. Complete circuit. We wanted to understand for circuit breaker and generator, what are the possible combinations? How many of them are critical? How many of these breakers are critical? If they are open and there's an attack that can close it, how this will impact? If a breaker is closed, what if someone open it? How this will impact it? So we did some kind of experiments to reflect. If you see this, generally the line should be 100% maximum overloaded. It should be less than 100 always, so that you have some capacity. If there's a huge demand, you can fulfill that. But if it is already 100 plus, lines is already overloaded, you don't have capacity to meet the requirement, right? So we did this test to understand what happened when attacker target these things, how this will behave. So we take out some circuit breakers here, in this case this one, in this case some others, right. So, in these two cases you see it is 108, 108 it is kind of manageable. If you take certain actions little bit, you can make it within 100%, but what if this goes 144, 183 and multiple lines are overloaded. This means this could be a serious scenario where you can't really handle it, or you don't know how to handle, right. So, those kind of the whole game is to understand those scenarios that can create huge impact on the system, and those we need to pay a little more attention to those scenarios. So, those breakers that we have used in the scenario 1 are more critical than others. So, you pay more attention to those breakers. Every time someone open or close them, you want to check them, right. Others are also important, but as not as the in the first case. So, this kind of analysis will help you to understand the worst case scenarios. You can simulate those. What else? So, you see this is bus from to as says whether this bus is closed, device type, you got breaker, lines and so on. They all are closed at this point of time. You got to see what is their power, active and reactive power, megawatt, megawatt and so on. So, these are the power quantities. You can also play with this saying what if attacker targets systems and then change generator and change these quantities, right. In a region there is a demand of let us say 100 megawatt, where you decrease the capacity of generator to 50 by manipulating these numbers. So, since you are not able to fulfill that demand, line will be overloaded. There is a huge demand, but then you do not have supply. So, we did this kind of testing with individual assets. You pick one critical asset at a time, one path. What when you mix those? I might play with multiple assets at the same time, how this will impact. Because detection is very, very difficult. You don't know whether it's a routine command, whether this is an attack, or if it is a coordinated attack, you can't really easily detect it. But what we can do is understand if something like this happens, how this will impact, and what are the possible solutions we have at this point of time to reduce the impact, negative impact, mitigating the impact. So, we look around the static assets as I said, but we also look around some dynamic assets which are not just the devices, but the processes itself, the functions, the data which are critical to the system. And then you run the experiment, what if someone captured that data? What if someone changed the process, changed the code, PLC, somebody compromised PLC and changed the logic? Yeah. So, what will happen to the system? So, in this scenario, if you see, it says in figure 1, relay and branch 4, 5 nodes with probability of compromise added as input to the dependent model. So, which is 4, 5. Can't see clearly. But the whole point we wanted to understand, for example, as an attacker targeting a generator, we wanted to see which of the assets having direct impact, which of the assets having indirect impact. So, if you see impacted, no impact, right. Then you see what will be the transmission line capacity. This seems to be normal. This seems to be almost overloaded, but having some capacity to handle it. This is overloaded, requires immediate actions. And we did some kind of risk assessment. We've talked about this, yeah, with CBSS and IBSS. So, you also wanted to understand what is the cyber risk level in terms of a score. So, here we say criticality is probability of compromise and factoring impact, right. So, in a specific scenario, if you have vulnerability in a system having a higher chance of compromise compared to an asset that's kind of bit secure or not having vulnerability. Then you look around some other factor, for example, attack vector. What does the attack vector look like? How complex it is? Privilege required? Does it require any privilege? In order to perform attack, do you need some permissions? Do you need to hack something else? Do you need some keys? Yeah. So you pick all those parameters into this. User interactions. Does it need to start with the user? Does it require spear phishing? You know. So you take into consideration all those things, and then you create scenarios and understand what will be the probability of this kind of attack. And in order to perform attack, what attacker needs actually, and how easy or difficult to get those things, right? And impact in terms of how they're impacting your different areas, different buses, different devices that you got. Right, so I'll just pick few more topics. So this was the whole kind of framework that we have designed. We have also created a simulator, and this will help us testing those environment. Now, for power system, we used a tool called PowerWord. One of the reason I can't show you this is because this is a commercialized version that we are using. There's also a freely version available. If you Google it, PowerWord software, there's always a freely, I guess it's a free version available for 3 buses. So it's a simplistic version that we have used here that I shown you, which is for educational purpose. You can download it free of cost and then play around it. But then since we were using scalable systems, which we're having, so this software supports, I guess, 250,000 buses, and so you can really scale up the real system. In a complex system, what will happen if attacker target XYZ, multiple devices, how this system should behave. It has got power system algorithms and so on, everything built. You can run and test. What is zero knowledge proof? Have you heard this term, zero knowledge proof? Okay, whenever we need to get into a system, it asks for some sort of authentication. And in most of the time, we need to insert a user ID and password to it, right? Now, if you got a system that asking you every hour in order to log in, every hour just log out, right? You end up by putting user ID password multiple times, or every day, let's say, not hour. But still in a month, you are putting it 30 times. Your probability of someone to hack your password is higher, much higher, depending on how many times you are putting it. Whether it's safe or not, there's always a probability for using it many times. So the whole concept of zero knowledge proof says 2 parties should be able to authenticate each other without knowing the actual user ID or password in a way. I need to know something. You need to send me something over the network, but not exactly key. No key, no password. That's what says zero knowledge proof. I should be able to understand that you are the correct person without sending me any key, without sending me any password, and without sending me any confidential information. Yeah. Now there are 2 ways of this: interactive, non-interactive. Interactive means both parties are online in a way, and you have to immediately solve the puzzle, for example, and send it back. Non-interactive, you can take your time to do this. So there are 3 properties for zero knowledge proof. 1, completeness. We say if the statement is true, honest verifier will convince by the honest prover. Verifier who is verifying, prover who is proving that he is the part of the system. Soundness, if the statement is false, no dishonest prover can convince the honest verifier. Proof systems are truthful and do not allow cheating. And third is zero knowledge. If the statement is true, no verifier learns anything other than the fact that the statement is true. Yeah? So it's not like you are sending over the net with the password or whatever and they are learning over it. Whatever you are sending, Even somebody has access to it, they don't learn any information other than the fact that whether you belongs to it or not. Yeah. Simplistic example, let us say when you are registering to a system, you are storing a number x or you are storing your key, let us say. Now, as a verifier, I can send you a function. Every time I will send you a random function. I will say whatever number you have, send me the square of that. And in my database, I already have that number. When you send me the square of that, I can compute that and compare. Next time I will send you, can you do this exponentiation of this, for example? Yeah. Again, I am talking about very simplistic function, but the simplest function could be complex a bit. That takes time to compute correctly, but then these are the ways. You just get the outcome over the network, not the actual information. Right? Now, in this one, you need to understand sometimes we believe that environment is secure. No one can modifying those, capturing those things. Right? If that is the case, then you make the system more complex. Maybe you are sending something in an encrypted form, encrypting and then decrypting and so on and so forth. But the whole basic understanding is that they will send you the outcome of that function, and then you compare this without sending any key, without sending any passwords. So, generally zero knowledge proof is also kind of getting very popular with the zero level of trust. Yeah? Zero trust, we talk about this, where we say we don't really trust any other person, we don't really trust devices, don't trust each other. So, we are designing a system where nobody trusts each other. Then can we create a secure environment where we can verify every time everything that we are using? Okay. The second important aspect is secret shamer secret sharing. Have you heard about this algorithm before? What it does? So, generally when we, for example, if we are doing encryption, we need a key. Yeah. And generally we are storing the key on our laptop, for example, or a system that we are using, right? Or in some places. What this algorithm allows us, you can distribute the secret. I am calling it secret, let us say. You can distribute the secret, you can divide the secret into parts and store those parts separately. So, in this example, you see this is the key. Rather than I am storing it on my device, I can store part of this, I can divide the whole key into 3 parts and then storing each part in different clouds. In worst case, when there is an attack, someone hack this, they can't get this key, because they are getting part of the key, but not the key actually, right. But then this algorithm also have this property which says if I divide a secret in n numbers, if I got any t number out of n, I can reconstruct the original. What does it mean? So, this algorithm allows you to reconstruct the original secret despite of the fact you do not have n shares. Let us say there is a lock where 5 people needs to be there, or 5 keys should be used in order to lock something. Every time you need those 5 people to be here. If there are any 4, they won't be able to do. Now, this algorithm says if any 2, any 3 are there, you should be able to unlock it. So, it gives you a little flexibility in a way. If some shares are not lost in the network, you can still reconstruct your original thing, right. So, this algorithm is really important, and in order to keep your secrets at different places, distribute among users and so on. What is secure multi-party computation? Multi-party computation, there are multiple parties involved and they are computing something. When we say secure, it means in a secure environment. So, in this case, there are 4 users, 4 people, and they are having their wealth, which is kind of a message or text in an encrypted form. And we got a system that wanted to know who is the richest out of these 4. So these people don't want to reveal what what is the value they have. They don't want to reveal to each other, but they want to compute something. In this case, they want to make a comparison saying who is the richest person without showing the actual numbers. Now, this kind of application is very, very popular in terms of data privacy preservation cases, where you don't want to reveal the exact numbers, exact data, but then you just want to learn or do some computations over data, right? Again, they are not suitable in all situations because they generate a lot of computation as well. But in some situation where we need to, where the privacy of data is more important than others, in those situations we can use secure party built computations. So, for example, it's another example, say calculating average of hourly wages. So, Alice getting $100 per hour, Bob getting $12 per hour, and Cynthia getting $22 per hour, right. So, they are dividing their wage per hour into 4 breakdowns, each of these, and then you are passing this to this server, the first share to, let us say this, and so on. So, 2, 4, 2 getting here, 1, 2, 4, and so forth, right. So, you are storing these in 4 different places, let us say. Then let us say calculate the average of 3 numbers, then you are getting average of it, which is 8 divided by 3, this is 7 divided by 3, and so on and so forth. You are getting the average and then summing it up. So, what we are doing here essentially, we are doing the similar calculation, but we are not directly doing calculation on it. Yeah. If you do calculation here, then you need to reveal these numbers exactly. So, what we are doing, we are fractioning these numbers into parts, sharing these parts to different entities or users. They are getting the average, sending back to the server who wants to know the result, and they can get the average out of it. So, these are the way where you can protect the privacy of data without sending the actual data, but you can compute over it. Functional encryption, sometimes you do not want to reveal the whole data, but part of data. For example, you wanted to know if this email is spam or not, right. There is a scanner that if you run it, it can check whether the email is scanned or not, or filter that you can apply. So, if you apply a filter on your network, it will learn all the emails, right. But we are not interested in that. We do not want to reveal all the messages. But I am more interested just to know whether this particular email is a spam or not. So, I can create functional encryption, encrypt that particular email, send it to the scanner, give them a key, and they can access that rather than accessing everything, right. So, in many situations, in many practical data sets, you can't share the whole records. You can only share part of the information, and these functions will help there. Homomorphic encryption. Okay, you were talking about homomorphic the other day, right? Homomorphic. What is homomorphic encryption? What it does?
Yeah, it's like kind of, for example, in a situation of federated learning, like when in a federated learning there is environment, like we share the data to local clans, like local models. So during aggregation time, there is issue of privacy issues. For example, we can take the case of healthcare, healthcare information of patients. So it's not like expected to be that the information of the patient, it shouldn't be like revealed. So during that time, we can use this more encryption algorithm to protect the privacy of individual patients.
Okay.
No need to like.
Okay, okay, got it. So encryption has been evolved over the years. We used to have very simple encryption techniques earlier. The whole point is to, it started at the time when you see there was a, if you've seen those in old movies or historical movies where there's a blank paper, if you bring that paper close to the light or the fire, then you can see some scripts kind of. So it started from there, where it started with something called hiding the text, secret hiding. Yeah, so they were hiding the writing on paper with a special pen that you can read it in certain type of lights. Then they started hiding in images. We call it steganography, where you hide pattern data and changing the pixels, changing the colors of the image, send it. People can extract that information. Then we got simplistic encryption, where we say substitution cipher. Then we got AES, DES, all those encryptions, which are encrypting the whole entire data, right? And in order to get this, you have to decrypt with a key to get the whole data. Now, what we are saying, we don't want to decrypt data. So there might be the case where, let's say, smart meters, they are at household, they are sending their unit every half an hour, sending to the control center or the billing unit, right? There's a person operator sitting at there. They have access to all data. If the data is in plain text, they can look at. If the data, or someone can compromise as well. If data is encrypted with, let's say, AES, they need the key to decrypt in order to get to know what are the units utilized by certain households, right? Now, what is the problem there? They can still have access to the actual data. Now, what we want, our intention is to get to know what is the total number of unit for the day in this region. Right? In this region, what is the total consumption for today, for example. So, you collect data from there, that is the encrypted data, but your intention is just to compute the sum. Whatever reading you have, you just want a unit, you want to compute a sum over it, so that you get to know the total number. We can achieve these using homomorphic encryption without decrypting it. So, homomorphic encryption is one of the techniques where you can encrypt data, you can perform certain computation without decrypting the data. Yeah? So, computation over the encrypted data. So, it could be something is called additive homomorphic, where you can perform addition, multiplicative homomorphic, where you can perform multiplications over the data, encrypted data, or fully you can perform multiple operations. Okay, just talk about last thing before we get blockchain. What is blockchain? Again, application of blockchain is everywhere, even in energy systems where you want to keep record, track. It's used for tracking and so on. Now, when blockchain came, people were saying, "Oh, this will not work." What is the why blockchain is so popular now? I believe everybody know what, at least heard this blockchain. Yeah, what is blockchain? Why we are using it? Blockchain is a distributed ledger that keeps record of all the transactions. For example, you are making transactions, you are depositing, withdrawing from a bank. Who holds the record? Bank. Yeah?
Normal situations.
Right. Banks hold all the records. If there is no RBI, no central body to regulate it, they might manipulate data for their benefit, whatever. Yeah? And this has happened always when you have business. People are selling and buying, hiding things. Yeah? When it comes to text saying this product we sold in 100 rupees, however they sold at 200 rupees. So they can manipulate things, for example. Blockchain records everything, and it does not give control to one person. That's why it's a chain of blocks. Yeah. So let's say I'm creating a blockchain and creating a block every hour. So I will record how many transactions are being made in 1 hour. These are my blocks. I'm also creating hash of this block, so that anyone can also verify the blocks is not been tampered. This data has not been tampered. Yeah, we know hashing now. And then you are connecting these blocks. This is the first block, second block, third block, and so on. Every hour you are creating a block attaching to this. Now we have variety of blocks, blockchain technology nowadays. Yeah. Something is called public blockchain, private blockchain. Public blockchain means anyone can be part of it. Private blockchain, only specific people could be part of it. There's also something called miners in this. So as I said, it's a distributed ledger. No one centrally can control it. Whenever, so I'm talking about these blocks. So in order to attach one block to the chain, there's some process. You need to make certain computations, and there's some number that particular block got. That block will attach to this. And miners are the people who do these computations. If it's a public blockchain, you could be part of it, and maybe you are getting some incentive out of it. If you're using your laptop, you're giving your resources in a way. Right? Let's say if 100 people involved, 100 people working as a miner, they all will do the same thing. So if somebody is saying, I got result 10, everybody know whether it's a 10 or not. Right? You attach to a block, any point of time you cannot change it. If you change a copy, other 99 have a different copy of it. And you cannot influence 99 people. You might influence 1 or 2 as well, because they are friends or whatever. And sometimes you don't know who are the miners. So it's creating a system where it's almost impossible to influence miners. And everybody, until they see the same copy, majority when they agree on something, that becomes part of the chain. And at any point of time, you can trace the whole chain. What were the blocks, what were the transactions were added to this. And no one can change the amount or whatever date and time. Yeah. So this could be applicable in any scenarios. Supply of drugs in healthcare. What medicines you are selling, sending, what time. Delivery in power systems, units, water, what is the rate, things like that. So blockchain has a very wide variety of applications. So again, the number of blockchain example, Ethereum, Hyperledger, I don't know if you have heard these, but there are so many. One of the, again, they also have something called, what is called contract, smart contract. We call it smart contract. Now, the role of a smart contract is to, in a way, automate things. Let's say there's a company that is doing a business in terms of buying and selling house. They got customer who wants to buy house, the people who want to sell their house. Now, seller says, I will sell my house if it is 20 crore, for example, at least this amount I want. There are buyers, they have their own constraint. So we can write a contract. Now, we don't want to do a lot of deals in terms of negotiation or whatever. We write a contract. These are the conditions in order to buy it. The buying amount should be at least 20 crore. We will not be selling less than this amount. These are the conditions. These are the documents. You have to verify X, Y, Z. Creating a digital contract, putting this condition. Whoever buyers meet this requirement and interested, trigger this contract. And the system automatically sell the product, sell the house to them. There's no manual involvement or dealing. We create a smart contract. Once that condition met, it will execute, and people will buy and sell. Yeah, and this will be recorded since it's part of chain. You can always go back and check in which years what amount was you sold the houses. So there are so many applications. The number of startups working on blockchains around the world. There are so many. Right. So just last slide before we stop here. Differential privacy. I think I touched it a bit, but just wanted to give you more sense. So what is differential privacy? We talk about it, yeah. We say we instead of sending or sharing the actual data, we want to introduce some noise to it, so that we don't reveal the actual data. There are two ways of doing so. One, now the very basic thing when we say privacy of data, people might think anonymizing this. Yeah, I have a record of student ID, name, what subject, program, whatever. If I wanted to know in this particular program how many students are there, yeah, I need part of the information from this table or record, whatever you call it. So what I can do, I can hide name, ID, yeah, and then reveal only the student strength in some way, compute something or whatever. That is the anonymization. That is a bit different from this. I wanted to know the average marks of the student of this class. I can anonymize the student name and ID, but still I have to show the marks. Yeah, if people wanted to know what is the marks look like and the average. What I can do, instead of giving the exact marks, I can put some noise. Yeah, I can have my own marking. Instead of 40, I will make it 45. If somebody got 30, I will say 36. I'll put some noise so that it looks like similar, but then not the actual data, so that if they cannot misuse it in a way. So we can do in two ways differential privacy. One, you're collecting data from different users. This is the aggregator or third party, and they are introducing noise before performing any statistics. Right? Because whatever statistics, sometimes what happens once you got this outcome, people might reveal or get to see something. So we introduce noise so that even if you are doing some calculation, you won't be able to get it correctly. Second part, where users are not trusting the third party, they themselves introduce noise and then sending it to this. Right? But in order to do so, you need to know what noise you have introduced, so that at the end you can reduce that noise from the outcome to get to know actual, if you need to know. Right? So the examples, for example, Google introduced differential privacy tools called randomized aggregator privacy, ordinal response in Chrome browsers. It helps Google to analyze, draw insights from browser usage while preventing sensitive information being traced. So they're tracking, they're getting your data, but not the actual data with some noise. Right, so we'll stop here and have a 15-minute break, yeah? And then we'll do the lab exercise. What happened? Oh, sorry. Yeah. Right. Welcome back. Now this is 1 hour tutorial, and what we wanted to do is, so I've created a program for password checker. It's in Python. Your job is to run it, understand different types of output that you're getting, and get a sense what this program does. Okay. So that is the first part. And second part, we have some analytical exercise. So we talked about the RSA yesterday, and there's a simple exercise how you can crack RSA. I'll talk about that in more detail, what I'm giving and what I'm expecting you to do. So how can you crack it if people haven't implemented RSA in a proper way? So implementation is really important. If you're not implementing it correctly, there's always possible someone can crack your system. So we'll start with the first one. So there is a program called password-checker. I've given some of the details. So it is based on something called regular expressions. When you put your input, it will look at the strings, pass to the regular expressions, and see, regular expressions, yeah, automata, and you, okay, right. And yeah, so you say check with the example when the code prints password is weak, check the example when the password is strong. So you need to tell me when you see the password is strong as an outcome and when you see password is weak. Okay, let's do it. Since it's a standalone program, it should work on Google Colab or online editors, whatever. It should work everywhere, I guess. So when you run the program on terminal, it will ask you, you have to input some password. And then it will check whether the password is strong or not as per the instructions given inside. Working, yeah, straight. What? You enter invalid password. Okay. Can you go back to the code? Where's the invalid? Sorry. Else.
There are four conditions like lowercase, uppercase, special character, and number. So I fulfill all the conditions like.
Okay, give me a minute. Can you rerun it? writing in the code.
Invalid password listed.
And length is more than 8, yeah, automatically.
Okay, so one should be at least 8 now. Like at least like minimum 8,
It is, yeah.
not maximum.
Maximum, no, minimum 8.
Okay, so
Yeah. So your password contain blah blah blah.
4, 1, 6 and 1 like all three conditions.
How do you run it from?
From
From here. Okay. I think there's some typo. Let me fix this. Can you? So I send you the another code. Maybe this the program I have some bugs. I send you another one. Can you distribute this?
1 minute, sir.
The code. Can you run on your system before we do so?
Yeah, one is working.
What does it say? We say invalid number, yeah?
It's saying weak. It is saying weak also. One condition is still bad.
So there are some bugs. That means, yeah, it's not working perfectly.
We will work it.
If you open the other one, the one I send you now, and run it.
Share program and then
So showing some bugs, I was just kind of trying to do fix this. So I guess there were some typos. I missed some things.
yes,
Yeah. Okay.
this one is working.
All right. So there's another code. Huh? There's another code I sent. This one, yeah. Yeah. Change the code here. So there's another file you can. So I guess it has got some bugs. So there's another file we send it. So that one you can use it. Is it work? You can check this if this is working. It's working right, yeah? Okay. Is it working now? Okay. What it does? What is strong?
Or like I am getting invalid for one. I have not.
No, are you using the last program, the recent one? They sent another copy. It was having some bugs. So if you look at the, yeah, another code, it should not say invalid. There were some issues. It will say invalid if you are not putting password of 8-digit at least. Yeah, that's why I'm saying it has bugs. If you run the new one, it should work.
The password is strong.
So how we are defining strong?
We are using the mentioned criteria like special case,
Right.
special characters, digit, uppercase, lowercase.
Exactly. So if you are asking any users to put a password, you can put these conditions on the checks. When they're creating a password, if this meets the criteria, you allow it, otherwise you discard it. Now what is happening in the code itself?
So we have like firstly like length should be greater than or equal to 8.
Yeah.
We have mentioned all the criteria like there should be special characters, lowercase, uppercase.
So what are the syntax for that?
Here
How are you matching this? What is this first one?
it's Boolean, there is a dot match,
Yeah.
and then this is
So what are you matching here?
it's just a regular expression that says you should first is dot, okay, then slash you should include all the regular expression like this now only. Every regular expression like this is optional. Every regular
Why I'm putting
expression-
star asterisk?
asterisk means here means like clean होता है ना, clean like should clean all and given in brackets like small a to z.
And what is happening in the second line? So I'm saying small a to z and then asterisk, capital, then asterisk. What does asterisk does?
Include this and include this. Like
So in the regular expression, there's something called plus and
Digits.
sorry.
Actually, you mean small digits or digits in
So small we are using against D because D, if you're putting just D, it might not recognize. For example, n slash n or so. That's why we would put slash, but there's no meaning for that.
regular expression is the next line.
Yeah. So similarly, it doesn't recognize D. If you just put it will understand something else. So just putting slash after this, so that it recognize D as a individual digit. So on the first one, it's checking whatever input we are doing, whether it's first of all it should be at least 8-digit long. If that is the case, it will look and check whether there should be at least one digit.
This is optional.
So when you put this asterisk out after this asterisk means zero or many, zero or many. So it could be zero, it could be many. If you're not putting, for sometimes we put plus. Plus means one and any, one and many. Yeah. So in regular expression, if you're not putting even this asterisk, it means, so I have created 4 brackets, parentheses, one for digit, one for lower, uppercase, special symbols. So the first line will say there should be at least one digit, there should be at least one lowercase, at least one this and this. Second line says zero or many. It could be zero, it could not be there.
Question mark is symbolized option.
Question mark simply checking the conditions. That's why use for part of regular expression when it checks the conditions.
But when we put this question mark somewhere in between, it signifies optional, I think.
Where? No, sorry. Because generally when you say question mark equals to, so you're checking a certain condition. So in this case, we are matching the input string with one of these expressions where it match. So as soon as you got to say there's no digit, it will just switch here, which says 0 or 1. So 0 or many. So that means in this case they could not be a digit. So if that is the case, it will say password is weak. You are missing any of these four. If you have only these four, at least one, then only it will say strong. Otherwise, it will say password is weak. And then simply you're just computing how many lower cases you got, how many numbers you got, and then printing them. Yeah, you count. So just countering those, whether the string belongs to one of these. Yeah, if yes, you increase the counter by one, and then you count at the end printing that. Right, all good? Is it working? What is happening? What is happening here? Okay. We'll come back. Okay. Is it working for you guys? What is the learning? What is happening in the code? Yeah, password weak or strong, but what is happening in the code? What is the regular expression you see? What is happening here? What is the use of regular expression here? Why we are using it?
It makes a pattern of combinations of.
Right. What we want as a user, we asking a string input, and then we are defining regular expression every digit whether it belongs to one of those or not. So in the first line, we have four parentheses, one for digit, one for lowercase, uppercase, special symbols. Right? And in second line, we have the same thing, but we are saying asterisk. We are putting asterisk after D, after this, after this. So asterisk here in regular expression, it represents zero or many. Zero means they cannot be a digit. So if that's the case, we will say password is weak. So if you have combination of a digit, lowercase, uppercase, and special symbol, then only it will say strong. If any of those is missing, if the password is weak. And then it's just simply counting. So based on the string, first character of the string, it will read it. It belongs to one of these four, lowercase. It belongs to lowercase, it will increase the counter. It belongs to uppercase, so you read all the string, belongs to one of those, increase the counter as it meets, and then printing them. Right? So our goal here is to learn what functions we have used within the program, what they do. And yeah, okay. How about you guys? All good?
Yes.
Working? What is happening here in the code? Can we do it in another way? Instead of using regular expression, can I do it another way? Yes or no? Of course, yes. There could be several ways of writing a program, isn't it? A regular expression is much easier, much efficient because it gives you flexibility in a way. You just pass a string, match the expression, and then it's a Boolean operation, yes or no. If it matches yes, doesn't match, true, false. In this case, what is happening in the first line? So you're checking the length of your input. If it is at least 8 digit, it will proceed. If not, it will simply say your password is invalid. Somewhere we are printing this one, yeah? So it will jump to else, say you have entered invalid password, it's not 8 digits long. If the password is 8 digit long, what it will do? It will execute the next line. It will say if regular expression matches to what you are passing to digits. So I got 4 parentheses, one for digit, one for lowercase, one for uppercase, one for special symbols. Yeah, it matches with the password, the string you are entering equals to true. It will say password is strong. Else if this belongs to these 4 factor, now what is the difference between this and this? In the second one, you see I'm putting an asterisk after this, after D, after lower cases, upper cases, and so on. So in regular expressions, there are different ways to represent. So if you are putting a plus, plus means one and many. Asterisk means zero or many. Right? So there could be instance where this particular digit can be part of the string, cannot be part of string. So the password will only be considered strong when you are putting all these 4 things. Then it will say strong. If it is missing any of these 4, it will print password is weak. And that's why if you are putting a number, your password where it doesn't have any digits, any numbers, then it will say weak because it doesn't get the first part. First part executes saying digit cannot be there, can be there, cannot be there. So it will say password weak. But on the first one, there has to be at least one digit. Have to have one digit at least. So if you meet all 4 criteria, then you can say password strong. If no, you can say password weak. And then simply we are just matching the input and then increasing the counter. If your password digit, first digit, let's say lowercase, it will increase the counter for lowercase. If the next digit is uppercase, it will increase the counter for for all the string digits you have, it will match one of these. Whether it would be a digit, it would be lowercase, uppercase, special symbol, it will increase the counter, and then simply printing the counters. Right? That's what we are doing. Now think about if you can do it another way. I'm not sure. What if we don't use regular expression and just create your own program where you can match? So you have to use a string. Is all working for you guys? Okay. For you? All good? Password strong, yeah? Okay, good. Okay,
यस सर
it's working now, yeah?
ये जो स्ट्रिंग है सर इसमें ये सारे जीरो होंगे तब वीक आएगा ना
Second वाले में if any of these is not there,
नॉट देयर
it will say weak. First condition says
शुड बी
there should be at least one digit, at least one lowercase, one uppercase, one special symbol.
यस सर
Simply, second one say in regular expression, if you are putting asterisk after this,
यस सर
it becomes 0 or 1.
जीरो
So it will match the condition. If digit is not there,
यस सर
it will print password is weak. If any lowercase is not there, it will put password is weak. So if any combination of 4 is not there, password is weak. In order to consider password strong, you have to have at least one digit, one lower symbol, one upper symbol, one special characters.
यस सर एंड व्हेन इट विल कम इनवैलिड
Invalid password if your password is not of 8 digit long. So that's why we say type of password should be at least 8 digit. If you are simply putting 4 digit password,
आउट ऑफ द कोड आई थिंक
no, if you just output 4 digit code,
हां यस सर
it it will just print it say invalid.
not invalid is not printing in this case it is out of the loop because it is coming na when length is greater than equal to it then it is going to enter otherwise it is out
Where it is? Sorry.
otherwise this else
Yeah, yeah.
should
So
be with this
no, yeah. So you can make it a little out. Yeah, and then should also print. Move it a little one tab back.
टैब से हो जाता है ना
हाँ, हो जाएगा. Yeah, should work.
now invalid coming initially
Yeah. Because it becomes part of the insider load. Yeah. That's okay.
अब ये कोड है इसको फिर शेयर
Huh?
share this code in the group
It's okay.
because
It's okay. It's okay. Just the minor typo. Are we done with this? Okay. Okay, let's move to the other one. The second exercise that we have, right? So yesterday I talked about RSA very briefly. Can I please get attention, please? Right. So what it's saying, check your availability if you can crack short RSA keys. It said determine the value of P and Q giving the following public and private keys. So generally when we talk about encryption, it's always saying do not use the same key again and again. Always generate a new key for any encryption operations, right? but there might be some repositories where you can find the pairs. Even if you're generating keys, there might be instances by having access of multiple pairs, I should be able to crack it. And that's the scenario like this. So what's giving you? It's giving you two things. One is public key, one is private key. I'm giving you a scenario, what is RSA look like. So what is, so if I just follow this algorithm, what are the parameters for public key? So if I'm calling saying public key is my N and an E. So one of the factors is common here, which is your N. So this is your N and E, and this is your N and D. What we need to do, we need to find out P and Q. N is the factor, N is P times Q. If you are able to derive P or Q, any of these, you can derive the other one. It's a N divided by P. Yeah, simple, or the Q. I've given some hint as well how you can crack it. It says you already have access to N, which is P times Q. This statement also reflects that one of these value will be at most at square root of N. What does it mean? There are two digits factoring each other, right? P times Q is N. If you are taking square root of N, one digit, either both values will be same. Let's say 25. 5 times 5 is 25. But in this case, we are saying P and Q are two different digits. They are not same. Right? It simply means one of digits will be lower than square root of N. One digit may be greater than square root of N. Right? That's what it says. Hence, you need to find a value, say V, less than square root of N. As I said, if you know the one digit, you can derive the other one. Compute N mod V and check for which value of V and go down in order to find out the next prime number below square root of N. So what we are saying, if we know N, we can easily compute square root of N. Yeah? We know that P and Q are prime numbers. If you know the square root of N, you need to go down and find out which is the next prime number. Yeah, going down, less than N, less than square root of N. So you find that number, try to divide it with N. If it breaks, you have cracked it. If not, find the next prime number, divide it, and so on. So I've given few hints as well. So I've given 4 prime numbers here, 4 or 5. That you can try. So what is N? So that's what it says. Simply P, since P and Q are always prime, you can use the next lower prime number just below the current V value. Hint trying this. Once you get such a value, this is your P. Simply calculate Q equals to N divide P. Compute N and check the original N. Now the P part is kind of homework, is optional. The couple of other videos which have different approach how you can crack RSA another way. Whenever you get time, you can listen to it. So let's do this. Yeah, what is N? Can we find the square root of N? What is the square root of N? So can you repeat now? Right, this one. Is this one? Okay. So if that is the square root, so this cannot be the answer because we are saying P and Q are different numbers. Then you go next one, which is the next lower prime number, possibly this one, the one I mentioned. Does it divide P? Sorry, does it divide N? So, you divide n by this number. Does it divide completely? Yeah. So, you say n divided by this number. You have to use calculations. No? So, if it is not dividing completely, then that is not the number. It should be, there should not be any fractional. What is the next number? You can try the other one. What is the next lower prime number? Third one. So, you can divide n with this number. If that does not work, go for the next one. So, answer is actually one of these. So that is the hint. But ideally, you can create a program like this that can do things for you rather than you do this manually. So, you can ask program to input n, you can compute square root of n, and then check what is the next prime number lower than this in this range. Start decrementing, you put a loop that can decrement those values and check whether this particular number is a prime. If no, decrease next, check it, and so on. So, you got to see list of prime numbers, and there you can apply for every prime number. You can try and divide by this number. It's not that difficult to do. Did you get the answer? Once you got the answer, just keep it with you. Don't disclose this. Let's see if you can find out. Did you get it, what I am saying? Okay, give me pen and paper, I'll show you. Give me pen. Okay. The RSA says you have two and P and Q, two prime numbers, where P is not equals to Q, right? You say n equals to P times Q. Once you know P, you can compute P times Q. So, in this example, you're given one is called public key, one is called private key. Public key I am saying n comma e is saying n comma d. So, by looking the equations, I can, if you go up, I can see what is n. N is 1 0 1 4 2 7 8 9 3 1 2 7 2 5 0 0 7. My E is 5, D is 8 9 0 4 1 7 4 1. Now, what I am saying, what the hint is, if you perform square root of n, yeah, you got two factor f1 times f2. Let's say if I am saying 25, the factor 5 and 5. Now, what I am saying, this is not the condition. One should be different, they are not equal. P and Q are not same. It means one of these numbers should be lower or up. If I am say 6, then this will go less than 4, less than 5. I am just saying 4 point something. If I am saying this 4, then this will be 6 point something. So, one of the number will be lower than this, square root of this number, and one of the number will be greater than this. Now, I am interested to know lower than number. You can pick any of those. Once you know one number, it's easy to derive the other number, you know, because you know n. Yeah. So that's what I'm saying. So what is the square? So what I'm saying, compute the square root of this. What is the square root of n? 100711415. So one number should be lower than this, one number should be greater than this. Now both are prime numbers. So you can pick any of those. Let's say we are deriving which is the lower number. So what is the lower prime number than this? So you can, I mean, you can program it, but manually see what is will be the next prime number in a decreasing order. Yeah. So let's say in this case this one. So say 1007111 which is very close to this. What I will do, I know n. I'll divide this n with this number. If it breaks, this is p, I'm assuming. One of these, I'm assuming this could be p, this is a prime number, but does it divide it completely? Do I get n where this is not a fractional number but an integer? It should be integer and prime number, of course. Right? Should not be fractional. If this doesn't divide completely, then this is not the number. So you go down, pick the next one. Then you might be p equals to 100711411, next one. Or you can write a loop simply. The loops can help you identify prime numbers. Then you apply same logic here. You divide, then this is the p. If no, pick the next lower number, maybe the next one, and so on and so forth. Yes, we just
Follow every number like one by one.
so I've given that answer is one of these, but you can generalize. You can write a program which can say you pick this number. So you can do this number. Start from here. This is not the answer actually because it's the square root. So you can say decrease this number by 1 and you check whether this number is a prime. Put some logic how you check prime number. You say no, then decrease further, check that number. So you can put a for loop from this number until a few digits, maybe 50 numbers or 100 numbers, should you get one of those. Whether this prime or not, if yes, then does it divide n completely? So you put these equations. If it divide it completely, that's the number. If no, then not. So you check if you can find it. The answer should be one of these. Did you get the logic now? You can, if you like, you can check the other upper part. Rather than going down, you can go up from here. Because one number will be greater than this, one number will be lower than this anyway.
I also check for lower and also check for upper.
No, you don't need to check both. What I'm saying, in this case, what we are saying, from this we are checking the lower, we're going down and checking the prime numbers to get q. As I said, one number will be lower, one number will be upper. If you want to, the other way is to, I can say p equals to n by q. I want to derive q. So I will go up. I'll pick what is the next prime number from there because I wanted to know this, not this one. In this case, we are getting this one. It's easy. If you know one, you can derive the other one, just the division. Yeah. Right. Did we get the answer? No, don't tell me. Just show me if you are able to. Let others to do this. They should do their own exercise.
Actually, this is not accepting every digit.
Every digit.
Yeah, it's one digit is remaining.
What does it mean?
Accepting, but we have done on mobile.
Okay. Yes.
Nine is coming.
Yes. That's good. But you can write it now. Can you write a program for this? Yeah, it's not loud. Let me show you how you can write. Give me a pen. Now you need to ask user n. E and D is there, but we are not really using them. Yeah. So you just ask n. Once you input n, you need to compute square root of n, which is whatever you call it. Yeah. Now what I'm saying, if n is a number that divides into two numbers, in this case we are saying these are two different numbers. When these two different numbers, what does it mean? Either this will be, let's say 4, then this will be 6 point something in order to make this number, or if this is 6, I'm saying greater than this, then this will be lower than this. This will be 4 times 4 point something something. So one number will be lower than this, other number will be greater than this, right? I'm calling this, let's say p, calling this as a q. Now I'm interested, what I know is n equals to p times q. If I know one, I can derive other one. So let's say I'm more interested to know in this scenario, any of those, I'm interested to know the lower number. So what I'm doing computing the square root and going down. So let's say square root is r, whatever its value. So you put a for loop for I equals to this number. Well, I is greater than, there's no need to go too many
Yeah.
lows, so I can say 10007 11000, let's say, last 3 digits, maybe one of those, yeah. And I'm saying I minus minus. So the loop will start from this number. This is not the answer because both factors are same. So this is definitely not the answer. I'll go down and check so within this loop, I'll check if I is a prime number. So you put some logic, how you check prime number. If I is prime number, I want to check. So I'm calling it as a p. If that is the case, then I'm saying p equals to I. Then that number is p. And then I can compute q equals to p divided by, n divided by p. If p is prime, I want to check whether it divides or not completely, n. If it divides completely without any fraction, then that is the answer. If not, keep this loop. Decrement the other value, check if it is not prime, you don't check it. If it is prime, go down. Does it divide completely? No. Decrement the loop, follow, repeat this. At some point you will see this divides it. Then you stop here and print it. So it's not as difficult, just a small loop to test it. Right, where we are. Is it working? Did you guys get the concept?
Yes, sir.
So what is the answer?
Sir, answer is this one
Yes.
because it is a prime number and
Oh, that's how you guess. Okay.
sir,
Okay.
now I add this all number and getting a 23. And 23 is not divisible by anything.
Sorry, what?
सर इन सभी को ऐड करेंगे तो 23 आएगा तो वो 23 तो प्राइम नंबर
Add करें.
ऐड मतलब सर प्लस
Why?
सर प्राइम नंबर सर डिविजिबिलिटी चेक कर सकते हैं ना वो प्राइम नंबर के टाइम पे वो 2 से चेक किया 3 से चेक किया उसे
Yeah, but we are checking all the prime numbers. So one of them is the answer. So you might get too many prime numbers, but answer is only one of them. So any 2 prime numbers, when you multiply them, you got this n.
yes sir
Yeah, not any other combination. So what I said is, okay, let me explain it again. What I'm saying, we know n, and we know n is p times q. If I have any number, it's a factor of 2 number. And I'm saying we can do square root sqrt, square root of n. Now in this case, both numbers are same. However, RSSA p is not equals to q. They're 2 different numbers. So that means in this case, if I'm picking 5 as one number, my other number would be 4 point something. And this one will become 6. Let's say if I'm picking this 6, it becomes 4 point something to multiply to make it 25. If I'm picking this less than this, let's say 4, then other number would be 6 point something. So one of the numbers is always less than this number and square root, and one number is always greater than the square root of it. So that's logic we are putting here. So and we are saying once we know one number, we can derive the other one because
because
simple. You already know n. Once you know this one, you can derive the other one. Now we can derive any of these. Now let's pick this one. We wanted to know number which is lower than the square root of n. Yeah. Now what is the square root of n in this case? This value. Right. What I can do, I can put a for loop. I equals to this number. I is greater than, again you can go up to 1, but there's no need to go up to 1, but let's say I'm saying 7110000. So I'm just checking for the last 3 digits as of now. So I minus minus. What I'm saying, I'm going down from this square root number and wanted to know what is the next prime number.
because less than this number, na?
One of them is less, one of them will be greater. You can pick any though. If you like, you can go up and check the other, this one. You can derive the other one. Yeah?
Yes, sir.
It's up to you. In this case, we are more interested in deriving this one,
Less value.
less value. Now, in this loop, what should happen? I will check if whether the I is prime. You put a logic,
Okay.
check whether this number is prime or not.
Mod, na?
Yeah? If this is prime,
Then,
I'm saying P equals to I.
okay, we have to write P.
I'm calling this as P, that particular.
Okay.
And I'm also computing saying Q equals to N divided by P. If this division, how you say mod, equals to 0, that means completely divides. There's no remainder, there's no fractional. Then that is correct. If no,
Then it is not P.
then you check the other number. Then you reduce, decrement this, check if this is prime. If not, get out of loop, reduce,
Calculate,
move to the next number until it's prime. If it is prime, go down, check this equation.
yes, sir.
If it divides completely, then that's the number. If no, then again you keep checking. Yeah? Once you know the one, you can derive the other one. So what is the learning here? How can you stop this attack? And you can manually do this, yeah, on papers. It's not as complex for pro computer to crack it. They can crack in seconds. Think about it. How can you stop it? See if you can write this program in Python. See. Okay, did you get the answer? Okay. What is the answer? No. Okay. Okay. Now what I'm saying in this, we know n. Yeah. And from RSA, we know P n equals to P times Q as a factor of two prime numbers. What I'm saying, compute square root of n. That's what I said. Why we are computing this? To build our understanding, let's say there's a number called 25. If you factor it, 5 times 5. Now in this case, we are saying P is not equals to Q. So if one of the number is 5, other will not 5. Right? So I might say this may be 4. If this is 4, this will be 6 point something. If you multiply, it becomes 25, for example. If I am saying this number is not lower, but it's a upper, if this is not 5, this is 6, then this becomes 4 point something. So you see, when you compute square root of number, one factor will always be lower than this number, which is 5, square root. One number always greater than 5. Yeah? So if you know any of these, you can derive the other one because we know Q equals to N by P. If you know P, you can derive Q, or P equals to N by Q. The other way. If you know Q, you can derive P. So you can follow any of these. In this particular method, we are more interested in knowing the lower number. You can follow, if you like, you can follow the upper number as well. That's up to you. Now what I'm saying, square root of n is 10007114115. Right?
Because the answer was 415.99 something.
That's fine. We are not interested in this number, but what we are saying, whatever the square root, the factor, one of the factor will be lower than this, and one of the factor will be upper than this number. Right? Now, and you can write a program for this. Now what I'm saying, I can put a for loop. I equals to, let's say I'm calling this whatever r. I equals to r. When I is greater than, now if you like, you can go up to 1, but there's no need to check too many things. So let's say I will just stop. I'll just check last 3 digits, for example. And I'm saying I minus minus. I want to check the lower number than this, so I'll decreasing this. I definitely know this is not the answer, because multiplying these two numbers may be the factor, maybe n, but then As per RSA, these two numbers are different. So this is not the answer definitely. But I want to check which is the lowest number from this, which is a prime that divides n. Yeah. So I'll start from this. Obviously this doesn't do. If you like, you can say -1 as well. There's no need to check for r because we already know r doesn't work. So what I'm going to check, I'll say if I is prime. You put a logic, how you check a number is prime or not. When it divides itself over, yeah? You put a logic. If I is prime, you want to check, let's say I'm saying it P, right? And I'm checking Q equals to NY P. If this number, lower number, the next lower number is prime and divides this, and I'm saying mod this equals to 0. Completely divide, there's no remainder, there's no fractional value. Then it completely divides, this is the answer. If it divides, but then there's some fractional value, it doesn't divide completely, that's not the answer. What it does, put in the for loop, pick the next value, check if it is prime. If no, get out of loop. There's no need to go further because we are interested only the prime numbers. If it is prime number, repeat this. You know, decrement the number, check it, check it.
Which is smaller than this number.
Yeah. We are interested in prime number lower than this.
Sir, but how will we get to know that this one will be the larger factor of n?
Because it is
What?
the square root.
Because it's a square root of n. A square root of n, where two factors, when you multiply two factor, let's say 9. Square root of 9 is so 3 times 3. So if you multiply 3 and 3, then you got 9. But in this case, P and N, they cannot be same. So definitely one number will be 2.9 whatever, and one will be 3 point or 4 point. You know, so one is lower than 3. Square root of n is 3 simply. So one number will be lower than 3, one number will be upper than 3. If you like, you can put a logic where you can check r plus 1, where this number is greater than something, the upper range, I plus plus. You can also do this thing, so you can derive in this number rather than this. And once you know this number, you can simply repeat this, get the other one.
So like if we here
So in this case, we are interested in knowing the lower number. That's why we're saying minus minus. Yeah, does it make sense? See if you can write a program. So what is the answer?
in program, but if we have to take P, here it is 415.
It's not p, it's n, right?
So the square root.
And so what is n? N equals to 1, 0, 1, 4, 2, 7, 8, 9, 3, 1, 2,
5007.
0, 7.
Square root of n comes to 0.
So if you say n divides this number lower than this, because this doesn't divide completely, so we know.
I have divided
So what is the next number?
11. So like 15 lower would be 11.
Yeah, so I've given 5 numbers actually as a hint. But even if I don't give you numbers, you can put this loop. This loop will automatically detect the number, determine which of these numbers is prime number. If yes, does it divide it completely? Yes, this is the answer. If that doesn't divide it completely, you keep decreasing number, checking if prime, divide this. So answer is one of these things. If you divide this number with one of these 5, you'll get the answer. But then put a loop, considering you don't know, you don't have this hint. You can just write a program. It's just a for loop, nothing. You just insert n, compute square root of n, put a loop,
And if we
check
have
the
given
prime,
some kind of
and that's it.
numerical,
Huh?
if we have given a numerical and we don't need to construct a program, do it by calculation.
No, you can do. I'm just saying you can write a program as well if you. Because manually you are doing this thing, but what if I change n? You have to do then all the calculation. Once you write a program, you just need to put n. Yeah, you can always change n and check it. Oh, okay. 5 more minutes. अभी time हुआ क्या अभी? It's working, yeah? What did you do?
I thought you can accept. Can accept. Just the sign is fine. And it calculates.
are you, so I'm not getting, so okay, what are you doing is just computing square root of n, okay,
Yes, sir.
then,
Then check prime,
okay,
square root is prime or not. Fit, then while loop.
does it divide, okay.
Yes, sir.
What if when this doesn't divide, what happened? Where are you decrementing those value or incrementing? Where's the loop?
No, sir, while loop.
While loop.
While loop.
So what the condition you are meeting in while loop?
If reminder is 0,
Okay.
then check.
No, not 0, not 0. No.
Okay, I'll come. Yeah. Are you guys able to make it? How about you? You got the answer. Okay. Good. Think about, can you write a program for this?
Yes, I'm trying.
Yeah. Create a for loop, nothing else. Pass input n as parameter. Once you know n, compute square root of n. Put a loop that start from the square root of n, goes down. Within the loop, you check whether this number is a prime. If yes, yeah, if this is a prime number, check whether it divides n. Yes, equals to 0, divides completely. Yes, that's the number. If no, decrement that number.
Then again start.
Check the condition. If it is no, if it is not a prime number, you don't need to check further. You just exit the loop, then check the next number. If it is prime, then check this condition. Does it divide n? Yes, you stop there. Yeah. How are you guys? You got the answer? Okay. We go 5 minutes. You get the answer?
अभी हम चलेगा गाइड होगा
Okay, let me help you.
ये तो p इंटू है तो वो बोल रहा है स्क्वायर के बराबर होगा
Okay, so what we are saying, these two keys are available to you publicly in some way.
Yes.
That's fine, it's fine. Now we know this is n, so this common factor is n.
And ये
Right. Now we know n is p times q. It's a factor of two number. What is the hint? Hint says compute square root of n. Why?
ये दोनों मल्टीप्लाई है तो दोनों 80 पास होगा
Because what we are saying, if there is a number called 25, for example, if you divide, say 5 times 5. Now in this condition, we are saying p is not equal to q. One of them could be 5, but other will not 5.
No, 6 maybe more than or less.
So yeah, so one number will be less than. If this is 4, this would be 6 point something. If this is 6, this would be 4 point something. So square root of n is 5 here in this case. So one of the numbers is always lower than this square root. One number is always upper than.
Okay.
Right. If we know one of these, we can derive other one because we know q equals to n by p.
Yes.
If you know p, you can derive q, or the other way. If you know
P and n by q.
q,
And
Right.
we have to guess from here.
even you don't need to guess. I'm just giving the logic. Let's say we are interested in this one, getting the lower number. Once you know lower, you can derive the other one easy, right?
But
Now-
this lower we'll get from square root.
Yeah. So that's why once you have n, we compute square root of n. Now we know square root of n is not the answer.
No, only we can get the
One number will be lower than this, one will upper. So lower of this is what we do. We'll go down from this number
yes,
and check the next prime number
yes.
in a decreasing.
Q should be prime.
Yeah, because let's say we are interested in lower number, we are calling it p. I'm interested to know what is p.
Lower and prime also.
Yeah, yeah. So if you decrease, so let's say I'm writing a for loop where I'm saying I equals to, let's say I'm calling this r. I is r. I is greater than.
For a square.
No. So So you have to check until this number is 7893. No, no. What is the
N.
what is n?
This one is N.
Okay, no. I want to check last 3 digits. No, no. I mean, you can run it until 1 up so to, no, no. Sorry, can you go up, go down the square root of n? So I give some hints. So let's say I'm interested in this 100711, and I'm saying last 3 digits. I want to explore. So I'm checking the last 3 digits in this loop only. If you like, you can make it up to 1. From this number up to 1, you can check all the primes. Yeah, I'm just checking because possibly we know one of the numbers between this range. But if you don't know, you can check it until the very bottom. And I'm saying I minus minus. So I'm starting from this number. Wanted to know, I wanted to go down. Wanted to check if I is prime. If this number going down, minus 1 is prime. If it is prime, I'm calling as P, for example. And checking if it divides mod equals to 0. It divides P. It divides n, sorry. If it divides, that means this is the number. If it doesn't divide completely, then that's not the number. So you will decrease, go down, pick the next lower number, check if it is prime. If it is not prime, there's no need to check anything. You'll go loop after loop, check the, once you got the next prime number, then again you check all the condition. If it divides, you got 0, that's the answer. If no, go in the loop. So in this case, I give 5 prime number, in a way, 5 lower numbers, and one of them is answer actually, that divides it. But the logic is, that's why we go for one of those. Once you know one, you can drive the, and that's one of the reason we are computing square root.
Yes, sir.
Okay, thank you. Right, so we are done with today's exercise. For task me, as I said, there are 2 videos. Whenever you get time, go through it. It's up to you. And then see you tomorrow then, everybody. Right.